In this video, I'm going to discuss Edexcel IAL Mathematics Mechanics M3 January 2023 paper. All the questions will be discussed in this video. Okay, so this is the first question. This graph is given and the area enclosed by y x equal 1 and the graph is shaded and named capital R. The equation of this graph equal y equal 1 plus root x. That's the equation of this graph. Y equal 1 plus root x. Okay, so the region R is rotated through 2 pi radians about x-axis. So they are rotating this region through 2 pi radius. So when you rotate it, you will get a shape like this. So same mirror shape. So we can find this value when x equals 0, y equal 1. X equals 0, y equal 1 is if you substitute this region origin. So when you put x equals 0, y equal 1. So here that's going to be 1 again. Say here we don't need that value. So it's going to be a region something like this. So this is like this. So when it is rotated, you will get a shape, a solid, something like this shape you will get it. So this is 1. And try to draw it in 3 dimensions. So this is 1, is it? So here also you'll get a shape something like this. Yeah. Okay. So there, by using the model and algebraic integration, that the volume S is 17 pi over 680. We had to show that. Okay. So normally the same method in the previous papers also I discussed. To find the volume of it, we need to imagine a smallest element with a known volume. Mostly we take it a disk inside. We take a disk inside. So the disk, something like this, we can imagine a disk inside, something like this, which has thickness dx, the height dx. This is the disk we are going to consider. At a distance x from O. So the radius of this disk is y. Radius is y. So I can imagine the disk of radius y and the height or the thickness dx at a distance x from it. So if I imagine there are several disks could be imagined, and if we can fill the whole solid by arranging those disks from origin to x equal 1, so we'll get the total shape of the given solid. The solid name is given S. So the solid name of this solid, after you rotate it through 2 pi radians, that solid is named S. Okay, so we can find the volume of a disk, pi r squared h. We know this for a disk, the volume of a disk of height h, or volume of disk height dx, which has radius r, but here the radius is y. So its volume delta V equal pi y squared dx. So like that we can consider several disks, those have different radius y, and if we find the volume of each and every disk, and when we sum or add all those volumes, we will get the total volume of the solid S. Okay, that's the idea. So we are doing the same thing again and again. Mostly we get the smallest scale of solid, normally disks. If it is 2-dimensional like a surface, something like a hollow shape if we are getting, we normally consider a ring. Remember that. For a solid, we consider a disk. For a hollow shape, when it is rotated, if we are getting a hollow shape, then we think about a ring. Okay, so that's the way we normally consider. Okay, so for ring, we consider the surface area. There they will ask about the surface area if it is a hollow shape. but since it's a solid shape, they ask the volume. Okay, so the volume of delta V, the volume, A parts, that's a part. So delta V equal to pi r squared means y squared, h is dx, right? So we'll substitute for y equal 1 plus root x, so pi 1 plus square root of x all things squared dx. So it's going to be expanded pi 1 plus x plus 2 root x dx. Okay, so this is the volume of a small scale, we imagine a disk. So the total volume means we imagine several disks like that. So the total volume of the given shape S is equal to sigma. We need to add several volumes of several disks inside. So sigma pi 1 plus x, I can instantly pi sigma delta V. Like this, several volumes we have to add it to get the actual volume of the whole volume of the solid S. So delta V means sigma pi 1 plus x plus 2 root x dx. With a summation with variable, I told that it will become integration. So pi integral 1 plus x plus 2 root x dx. So the variable should be from x equals 0 to x equal 1. That's all. If we solve it, we'll get the volume of the solid S. Okay, so that is V is equal to pi. It's going to be integration of 1 by 1 we're doing. This is x plus x squared by 2 plus this is 2 x to the power half. So integrate x to the power half means 3 by 2. This is 1 half plus 1, 3 by 2. So x to the power 3 by 2 over 3 by 2. The limits 0 to 1. Okay, so when you substitute 0, all x will get the value 0. So we don't need to consider that substitution. So finally, if I substitute 1 for each and everything, 1 plus 1 by 2, 1 squared is 1 plus 2, plus this 2 goes up 4 by 3 into 1, because x to the 1 to the power 3 by 2, 1, right? So that's okay. Now solve it. So it's going to be pi 6 is the LCM, 6 plus 3 plus 8. Am I correct? 6 plus 3 plus 8. So that's going to be 9, 17. So it's going to be V is equal to 17 pi over 8. That's the question they asked to show. 17 pi over 6, sorry. 17 pi over 6. Yeah, correct, 6. Okay, that's the total volume. Meter cube. The unit is in meter, so it's meter cube. Okay, B part show that the center of mass of S is 49 over 85 meter from O. So we need to find the center of mass of this solid S. So the definition is the same mathematical definition for center of mass. X bar is equal to sigma mi xi over sigma mi. That means the idea, I'll again tell, if I consider there are system of particles, lot of system of particles or system of objects at different distances from a point about which we are going to find the center of mass of the system of these particles or system of these objects. For example, this mass m1 at a distance x1 from it. This is m2 at a distance x2 from it. There is different particles. This is mn, mass mn, and its distance is xn from this. So the center of mass of this system of particles from this point about which we measured the mass of each and every particles or each and every object, and we are going to measure the center of mass of system of these particles from the same point. So it's given by sigma mi xi over sigma mi. That means the x bar is defined mathematically m1 x1 plus m2 x2 plus up to mn xn over divided by sigma mi. Sigma mi means the total mass of the particles in the system, that is m1 plus m2 plus m3 and so on up to mn. Right, so same idea we are going to do here also. We need to find the system center of mass of the solid S. For that, we imagine inside the solid disk. Already we found the volume of a disk and we found the total volume of the S. So we know the center of mass of the disk from O is at the distance x from it. And we assume the whole system, the solid S, could be filled with several disks arranged from O to this point. We can arrange several disks with different radius and we can fill the whole volume. So each and every disk at a distance x from O, and we know the center of mass of the disk will be at the center because we take uniform shape of it. So center of mass of each and every disk will be at the center of the disk. That will be at a distance x from O. So we are going to consider the sigma mi xi means mi is the mass of each and every disk that we consider. Xi is the distance of the disk, distance of the center of mass of the disk from O. Then sigma mi xi will be the addition of mi xi. Mi is the mass of the disk into xi is the distance of the center of mass of the disk from here, and divided by sigma mi. Sigma mi is the total mass of the disk that could fill the whole volume. That means that's the total mass of the solid S. Total mass of the solid S means total volume of the S into density of the material, or density what we consider mass per unit volume. Okay, so the same idea we are going to do here. So we first will write what could be the sigma mi. So first the definition of center of mass is x by equal sigma mi x or sigma mi. So sigma mi, how much could it be? Sigma mi is the total mass of the solid S, that is volume of the solid S into density. Normally in mathematics, M3, even mark scheme or even the textbooks, they take rho as one unit, but doesn't matter, we put it as rho, it will get cancelled. So we into rho. So volume we found it just now, that is 17 pi over 6 rho, that is sigma mi. Okay, so for each and every disk, that is mi xi is going to be mi, mass of a disk is volume of a disk, that is pi y squared, that is pi r squared, into dx, that is the volume of a disk, into rho, into xi. Xi is the distance of the center of mass of the disk from O, that is x into x. So that is going to be pi. So y squared, I substituted y is equal to square root 1 plus square root of x. So if you substitute that, you will get that will be 1 plus x plus 2 root x y squared, is it? This x I am writing here, x dx rho. Okay, so that's going to be mi. So the center of mass is given by sigma mi xi over sigma mi. So that is sigma mi xi means sigma pi 1 plus x plus 2 root x dx rho divided by sigma mi. We found it, that is 17 pi rho over 6. Okay, so here anyway this is a constant, we can use that later, but the numerator here there's a sigma with variables, so it's going to be an integration. So that's going to be integral pi multiplied into, here I can cancel rho can get cancelled, this 6 can go up, pi and pi can get cancelled. Anyway, so pi and pi get cancelled. So the 6 will go up, rho get cancelled, pi get cancelled. So it's going to be 6 over 17. 6 over 17 integral of multiply x plus x squared plus 2 x to the power 3 by 2 dx 0 to 1. 0 to 1. If you solve it, that will be the center of mass. So that will be 6 over 17 x squared by 2 plus x cube by 3 plus 2 x to the power of 5 by 2 over 5 by 2. The limits 0 to 1. Okay, I'll continue this here. So x bar is equal to, finally, x bar is equal to 16 over 17 into, substitute 1, so 1 by 2. Anyway, 0, if I substitute, every expression will become 0 because all are with x, so x equals 0, so I don't need to consider that one. So 1, if I substitute, half plus 1/3 plus 5 by 2 goes up, 4 by 5 into 1. Okay, so that's not 16, there's 6 over 17. So solve this ones. You'll get finally 49 over 85 meters. Okay, question number 2. A light elastic string AB has natural length L and modulus of elasticity 2 mg. The end A of the elastic string is attached to a fixed point. The other end B is attached to a particle of mass m. The particle is held in equilibrium with an elastic string taut and horizontal by a force of magnitude F. The line of action of the force and the elastic string lie in the same vertical plane. So they are in the same vertical plane. The direction of the force makes an angle alpha with vertical, where tan alpha is given 3 by 4. With the upward vertical, it makes tan alpha. Alpha is given with vertical, upward vertical, and tan alpha is 3 by 4. Find in terms of L the length AB. So I need to find the length AB. So it's under tension. So that means I need to find the extension, and I know the actual length, natural length L. So if I find the extension of the elastic rubber, elastic string AB, then extension plus L is the length AB, the question, is it? So for that, if I think about the particle, it's at rest. So how many forces acting on the particle? So particle is under action of 3 forces. One is the force F. The other one is the weight. So this is alpha. The other one is the second force is the weight mg. And there is tension due to the extension of the string. These are the 3 forces acting on the particle B. Okay, so since it's at rest, when it resolve all the forces to any direction, the resultant force must be equal to 0. Normally, we resolve it horizontally and vertically. But anywhere, whatever the direction I resolve all the forces, the resultant force in that direction must be equal to 0 because the particle is in equilibrium. So if I resolve it vertically, F cos alpha minus mg, this is horizontal force, has no vertical component because this is 90 degree, must be equal to 0. So F cos alpha equal to mg. Let it be first equation. If I resolve it horizontally, so along this direction, F sin alpha minus t is to the left, is equal to 0 because there is no resultant force in horizontal direction. Also, I can't resolve this weight horizontally because it's vertical. Vertical vector has no horizontal component. That means if you resolve a vector through 90 degree, it won't have any component. That will be equal to 0. So F sin alpha is equal to t. Okay, but we know that, but t is equal to lambda over L into x. We need to find the x. Lambda, we know that lambda is given as 2 mg, elasticity 2 mg. So that is going to be 2 mg over Lx. Therefore, f sine alpha equal T, that is 2mg over Lx. We'll take it as second equation. Okay, so tan alpha given, we'll find tan alpha by using these two equation under the condition the object is at the particle is at equilibrium, is it? By using that only we got these two equations. So divide second equation by the first equation. F sine alpha over f cos alpha is equal to 2mg x over L divided by mg, that means 1 over mg. mg will get cancelled, you will get 2x over L. That is, f will get cancelled, sine over cos tan alpha. So we are getting tan alpha equal 2x over L. But already they are giving, in the question they are saying tan alpha equal 3 by 4. They are giving it in the question 3 by 4. That means left side tan alpha, so right side must be the same quantity. So therefore 2x over L must be equal to 3 by 4. So x, find x. X is going to be 3L over 8. That is the extension. So they ask me to find the length AB. So AB is equal to, length AB is equal to L plus natural length plus the extension, that is x, that is L plus 3L over 8. So it's going to be 11L over 8. So that is the final answer. Okay, so question number 3 again related to center of mass. So in this question they are saying a square ABCD side 4A is made from a thin uniform cardboard. The center of the square is O, right? A circle with center O and radius 7A by 4 is then removed from the square of the form to create a template T. So that means earlier it was a cardboard with sides 4A, 4A, it's a square. From that, so the center of the square is O. So a circle is removed from the given square cardboard. The radius of the circle which is removed is 7A by 4. So the remaining cardboard is shown by shaded point with the dotted line. The shaded area is the portion remaining. Okay, we can find the area of it. So the area of the remaining portion is 4A all things squared. That is the area of the cardboard. 4A into 4A, that is 16A squared minus pi r squared. Pi into r is 7A by 4 all things squared. You will get the area of the remaining portion of the cardboard. Right. Now they are saying a cone. Like a shell, there means a conical shell is made by using the same cardboard. Means the density, surface density or the mass per unit area is the same because same material they are using. So mass per unit area of the cardboard is the same for both the template T and a conical shell. A conical shell is made such that its area of cross section, the hollow area, the bottom area, the radius is 7A by 4. So the area here 7A by 4, this area. So the, sorry, not area, the radius. So this radius of the base also 7A by 4. So that conical shell is kept such that its circular circumference exactly coincide with the circle created on the cardboard, and they are making a hat H by combining both together, and they are giving the surface area of the shell, the conical shell, the surface area of conical shell capital A is equal to pi RL, where L is the length of the slant. L is the length of the slant, right? So the question is, show that the exact distance of the center of mass of the hat edge from O is 175 pi A over 63 pi 120. Anyway, that's a question they ask. So here it's a shell, nothing related to volume. This is about surface area. So they are using the same material, same cardboard, means mass per unit area is the same. We'll find what could be the mass of the T. T is the, they are saying that's the cardboard remaining after removing the circular portion from the center. So this template T, what could be the mass and what could be the center of mass? So center of mass will be at the center, because if it is a uniform square, initially the center of mass will be at the center. From that a circle is removed such that the center of mass of the circle also O, means the remaining portion T will have the center of mass exactly at O, because the portion, circular portion removed also has the same center of mass. The square cardboard also has the center of mass O, means the center of mass of the T after removing the circular portion will be at O. Okay, that will be remaining O. So we'll find the first surface area of T, then we take mass per unit area rho, then we can find the mass of the template T. Same way we need to find the separately for a conical shell, what could be the mass? We can find the area, that is given pi RL. Only thing we need to find the L. R we know, that is 7A by 4. L we can find by using Pythagoras theorem. So for a conical shell, something like this. This is L. This A radius is given 7A by 4. This height also we know, the height is given 6A. The height is given 6A, means this is, by using Pythagoras theorem we can find the L. Okay, so then after finding the L, we will substitute and find the surface area of the conical shell. Multiply by the same surface density rho, you will get the mass of the conical shell. Right. Now we need to find the center of mass of the hat edge. Now both are combined. So they are sigma mi xi, sigma mi xi over sigma mi, or is equal to x bar into sigma mi. Sigma mi is the total mass of the template T and the conical shell. That total mass will be sigma mi. X bar is the center of mass of the hat from O. Sigma mi xi means we need to find the mass of the template T and its center of mass, multiply, plus mass of the conical shell into its center of mass from O. We know in the booklet it's given, handbook it's given, the center of mass of the conical shell is at 1/3 of the height edge. Is it? It's at a distance of 1/3 of the height edge. That's all. So we solve it, we'll get the x bar. Okay, so one by one we'll do. First we'll start with finding the surface area of the template T. Then we'll find the mass of the template T multiplied by density. We'll find the surface area of the conical shell, then multiply by rho. Then we'll use sigma mi xi over sigma mi is x bar. That's all. Right, okay, so we'll follow that method. Okay, so surface area of T equal the surface area of the square 4A all things squared minus pi r squared, we remove that. So minus pi r squared minus pi r squared, 7A over 4 all things squared. So when you solve, you will get that is 16A squared minus 49 pi A squared over 16. So mass of the T, will put MT, mass of the template T, MT is equal to multiply by density rho. Rho is the density, means mass per unit area. So multiply by it. So we will get 16 A squared rho minus 49 pi a squared rho over 16. Okay, so that's the mass of the T. Now for conical shell, we need to find the L. So for conical shell, L is equal to the length of the slant is equal to Pythagoras theorem, 6a squared plus 7a by 4, 7a by 4 all being square root. Okay, so solve it. That will be 25a over 4. 25a over 4 you will get it. Solve it and check. You will get 25a over 4, you will get it. Okay, so surface area of the conical shell. So mass of the conical shell that is mass of conical shell C stands for conical shell is equal to surface area pi RL into rho. So pi R is 7a by 4 into L is 25a over 4 rho. So that will be equal to 175 pi a squared rho over 16. Check it. That's the mass of the conical shell. Right. Now we are going to use the total. Now we can use the find the total mass of the system, or total mass of the head means this plus this, is it? So we'll use the same principles. X bar is equal to sigma mi xi over sigma mi. That's the definition. Sigma mi xi. So here we are not going to integrate because there are two different objects. What are they? Template T and the conical shell. So these are the two different objects merged together to form the head. So sigma mi means mass of the conical shell into the center of mass of the conical shell from O, because they asked you to find the center of mass of the head from O. So mass of the conical shell into center of mass of the conical shell from O plus mass of the template into center of mass of the conical center of mass of the template T from O divided by mi. Sigma mi means this plus this, that is mt, mass of the conical shell plus mass of the template. If we solve it, we know that we substitute and solve it, you will get x bar. Normally if it is a graph, we integrate because it's a variation in terms of x like that. But here it's only two objects. What are they? Two objects are merged together. So I told that this definition is applicable for many different, several identical or maybe different disks kept inside, like a graph questions, or you can use for 2 or 3 objects also. Here 2 objects are merged together to get the head H, right? So their mass of the conical shell into center of mass of the conical shell plus mass of the template T into center of mass of the conical template T, both are measured from O, divided by sigma mi means the total mass. Okay, so we'll continue that. So I think I better write the space I need, so I'll raise this portion. Okay, so x bar is equal to mass of the conical shell, we found it 175 pi a squared. Okay, rho will get cancelled finally. I show that pi a squared rho into xc, the distance of the center of mass of the conical shell from O, that is 1/3 of the height. So into 1/3 of the height, 6a, plus mass of the template, I erased it, mass of the template, we found it as 16a squared, 49 pi a squared, that is 16a squared, I'll write it here, say 16a squared minus 49 pi a squared over 16, that's the mass of the template, into xt. What is xt? Distance of the center of mass of the template T from O is 0 because its center of mass is at O. I already explained that because center of mass of the square is at O, center of mass of the circular portion removed also at O. So there's no change in the center of mass of the template, that will remain at O. So the distance of the center of mass of the template T from O is 0. So into 0 I should put. So I'll get 0 here. So I don't need to write this one here. It will become 0 because xt is 0. xt is 0. xt equals 0 from O. So that part becomes very simple because that value becomes 0 divided by MC, mass of the center of conical shell, 175 pi a square rho over 16 plus mass of the template, that is 16 a squared minus 49 pi a squared over 16 into rho. Okay, so here rho will get cancelled and you solve it. Now pi will get pi won't get cancelled because there is no pi here. So pi won't be get cancelled. So solve it. So you will get here, yeah, this 16 is missing here, over 16. Okay, now solve it. So when you solve, all the row will get it. This 16 I missed it. Okay, anyway, so this row, all the rows will get cancelled. So 175 a squared into a cube, 3 into 2, that will be 2 to 8. So it's going to be 175 numerator, 175 pi a cube over 8. Correct, no? 175 pi a cube over 8. So here 2, yeah, over 8 divided by here 175 pi a square, rho get cancelled. 175 pi a square over 16 minus 49 pi a square over 16 will become 126 pi a square over 16. 175 minus 49 will be 126 pi a square over 16. So that will become 126 over 16. We can write 63 over 8. So it's going to be 16a square. This 16a square will remain there. 16a square plus 63 pi a square over 8. Okay, so a square, a cube will get cancelled. We'll solve further. Yeah, sorry. So 8 into 16 is 128. 8, this 8 will get cancelled after multiplying this one. So a square, a cube. So there will be a in the numerator, 175 pi a. So x bar is going to be finally 175 pi a divided by 63 pi plus 16 into 8, 128. That's the answer. Lot of numbers, lot of variables are there. Careful when you are solving. But the principle is the same. Sigma mi xi over sigma mi is the center of mass. We need to identify how many objects are merged together to form the final object. So here only two objects, the template T and the conical shell merged together. So sigma mi xi means we have to consider only those two objects, the template and the conical shell, divided by total mass, that's all. Okay, question number 3b part, it's about something related to stability, what we learned in IGCSE O-level physics, IGCSE physics. You know that when there's a taller object, something like a table fan or something like pedestal fan or whatever it is, we learned that in ITCs it should have wide or larger surface area. The base must be largest surface, should have largest surface area. The reason, if this object is tilted, when it is tilted, say imagine the center of mass of this object is somewhere here. When you tilt it like this, what happens? When you tilt it something like this, so it's in contact here, the normal reaction will act here, the point of contact. So the line of action of the normal reaction will be this one. If the center of mass of the object is somewhere here, when you think about the moment about the contact point, due to the weight will act through the center of mass. So there are only two forces acting on the object. One is the normal reaction at the contact point, and the weight is acting from the center of mass, is it? So when you think about moment, turning effect about this contact point, the weight will provide a moment in clockwise direction this way. So the object will return to the position like this, even if it is tilted little bit due to the turning effect. Due to the turning effect by the weight of it, center of mass is here. So the object will have a clockwise direction of movement. It will return to this position. But in case when it is tilted, if the center of mass is somewhere here, the object has center of mass somewhere here, what will happen? The two forces are acting on it, the normal reaction and the weight. So when you think about the moment about the contact point, so only two forces, this normal reaction is passing through the point about which we consider the moment. So the weight is acting anti-clockwise direction. There is no other force to provide a clockwise movement to return to the same initial position. So what will happen? Due to the weight of it, the object will topple, so it will fall. But if the weight is acting along the same line of action of the normal reaction, say for example, if the center of mass is here, the normal reaction is here passing through this line, or the weight is acting through the same line. So when you consider moment about this point, there is no turning effect, zero. So it's all the limiting equilibrium in terms of toppling. So remember that if the weight is acting below this line of action of the normal reaction somewhere here, the center of mass is here, the object will return to the initial state position, the object is at stable position. If the center of mass is acting on other side, something like this, so when we consider moment about this point, the arc has no moment because it's passing through the point about which we are considering the moment. So the weight will provide turning effect, and there's no other force to balance this turning effect, so it will topple. But very unstable situation. But if the center of mass, the weight and the normal reaction are along the same vertical line, say something like this point is the center of mass, then the weight and the normal reaction will be along the same vertical line. Weight and the normal reaction, when the object is tilted at that position, the normal reaction and the weight, they are along the same line of action, means the object is at limiting equilibrium at in terms of toppling. So we want this idea for the B part. Okay, so before I draw the diagram related to limiting equilibrium in terms of toppling when the edge is kept on a slope, when we draw the edge, the hat in two-dimensional diagram, it will appear like this, is it? It will appear like this. This will be the diagram we can draw in terms of two dimension. So this is the O, the center. So this is A and B. Yeah, the opposite sides. So this length from here to here, the total length is the length of the square, which is 4A. From here to here, from O to this end would be 2A. This is also 2A. The center of mass of the edge is at a distance. Here we found it already. That is, we found it 100. So this is the distance of the center of mass. That we found, how much is it? This height is 175 pi A over 63 pi plus 128. So I'm going to draw this diagram on a slope. So remember that this is 2a, from here to here 4a. Right. Okay, so now the edge, the template edge, the hat edge is kept on a slope and it's raised, the angle alpha is changed such that the question says, the big part, a fixed rough plane is inclined to a horizontal at an angle alpha. The hat edge is placed on the plane with ABCD in contact with the plane and AB parallel to the line of greatest slope of the plane, right, the two-dimensional diagram. The plane is sufficiently rough to prevent the hat from sliding down the plane, given that the hat is on the point of toppling, means it's almost at the limiting equilibrium in terms of toppling. So that means the weight that passes through the center of mass of the hat. So this is G. G is denoted by, the center of mass is denoted by G. OG is the distance of the center of mass from O, what we found in the first part. That height we found it already in the first part, A part. So the weight is acting vertically down. The normal reaction is acting at A because it's about to topple. It's about to topple. So there's two lines, the normal reaction and the weight, they must act along the same vertical line. Okay, so they asked to write an expression for alpha. It's not a simple expression actually. So if I say this angle is alpha, this angle, this is 90 degree, weight is acting vertically down, this is a horizontal line. So this is 90 minus alpha. In this right angle triangle, this is 9, this is alpha, means this is 90 minus alpha. If this is 90 minus alpha, this is 90 minus alpha because it's an opposite angle, is it? That will be 90 minus alpha. Now consider the right angle triangle A, the point at which it's touching the hat, AOG. If you think about the right angle triangle AOG, what could be this angle? This angle, how much is it? This is alpha, this is 90, means this is 90 minus alpha. So this is 90 minus alpha because opposite angle. So in this right angle triangle AOG, and you consider the right angle triangle AOG, the right angle triangle AOG, if I call this angle theta, how much will be the theta? So this is alpha, this is 90, this is 90 minus alpha, this is 90 minus alpha. So theta plus 90 minus alpha, this is 90 minus alpha, plus 90 equal 180. A little bit too much I am writing, but anyway, simply I will get the expression, but I wrote it like this because in this right angle triangle, this is 90 minus alpha plus 90 minus alpha plus 90. This angle theta equal to 180. So solve it and get theta. How much will it be? You will get theta is equal to alpha. So this angle theta equal alpha. Is it? So now in this right angle triangle, tan alpha is equal to AO over OG. What is AO? AO means this is the edge of the hat. This is the center. A to B is 4A. So O to A is 2A. 2A over OG. That's the distance of the center of mass from O that we found in first part. That is 175 pi A over 63 pi plus 128. Solve it, you will get this is as 126. Yeah, when it goes up, this will be 126 to A will get cancelled. So 126 pi plus 256 over 175 pi. That is tan alpha. That's what they asked you to get the expression for tan. Simple, is it? Okay, question 4 about linear motion. A particle P is moving along x-axis at time t equals 0 seconds, where t in the range of 0 to 2 by 3. Particle P is x meters from the origin O and is moving with a velocity v in the positive x direction, where v is given 2x plus 1, 3 by 2. When t equals 0, p passes through O. So when t equals 0, it's at the origin. So if I say this is the origin, this is the origin O. So the particle is here when t equals 0. When t equals 0, the particle is here. It's moving in the positive x direction. Later at time t equal t, it is at distance x. This direction is taken positive. T equal t, it's moving towards right at a speed of v equal 2x plus 1 to the power of 3 by 2. So when t equals 0, it's at 0, x equals 0. So when t equals 0, the particle was at the position. The question is, find A part, find the value of x when the acceleration of p is 243. So we need to find the value of x when the acceleration of p is 243. So we need to get a relationship between acceleration and the x. Is it? The question is find the value of x when the acceleration is 243. Means we need to get a relationship between a and x. So we know the speed is given in 2x plus 1. So if we want to get the relationship between a and x, differentiate it. So we know that a part v equal 2x plus 1 3 by 2. Acceleration is equal to dv over dt, but it's given in x. So we can write this dv over dx in dx over dt. But we know dx over dt is v, so this I can write v dv over dx. Okay, so dv over dx we'll find it separately. dv over dx is equal to 3 by 2 when you differentiate 3 by 2, 2x plus 1 to the power minus means half into differentiating, say you will get 2. It's going to be 3, 2x plus 1 to the power of half. So A is going to be, A is equal to v dv over dx. So v, we know that v is equal to 2x plus 1, 3 by 2 into dv over dx, 3 into 2x plus 1 half to the power half square root. So it's going to be 3, 2x plus 1, 3 by 2 plus half. You need to multiply means you need to add the index. So it's going to be 4 by 2, that is that. Okay, so A equal 2x 3 into 2x plus 1 square. Is it? That is that. We can get in terms of V also, that is later for the next part. Okay, so when the acceleration is 243, substitute 243 equal 3 into 2x plus 1 square. 243 divided by 3, that is 81 equal 2x plus 1 all things square. Take square root, this become 9, 2x plus 1. So x is going to be 4 meters. So when the acceleration is 243, x is 4 meters. Okay, big part. Find v in terms of t. Okay, we need to get a relationship between v and t. V and t. We have v and x, but we need to get in terms of v and t. Okay, so for that, what can we do? You know A is equal to dv over dt, is it? A is equal to differentiation of velocity in terms of time. So dv over dt, but this is in terms of x, but we can replace 2x plus 1 all things squared in terms of v. So b part will go to that way. So b part, we know that v is equal to 2x plus 1 3 by 2. So how much will be 2x plus 1? So how much will be 2x plus 1? That means if you square the whole equation, it will become v squared equal 2x plus 1 to the power cube. Then take cube root of it, you will get v to the power 2 by 3 is equal to 2x plus 1. Is it? V to the power 2 by 3 is equal to 2x plus 1. Okay, so we'll take this as equation 1 what we use in the first part. Now I'm going to use that one, but we know that a is equal to 3 2x plus 1 square. That is 3 2x plus 1. 2x plus 1 equal v to the power 2 by 3. 3 into v to the power 2 by 3 all this square. That is 3 v to the power 4 by 3. That is a. Okay, so I got a relationship between a and b now. So a is equal to 3 v to the power 4 by 3. But we know that a equal dv over dt is equal to 3 v to the power 4 by 3. Now we can integrate integral of dv over v to the power 4 by 3 is equal to integral of 3, I can take it out, integral dt. Okay, how to put the limits? Now when t equals 0, how much will be the v? So they are saying when t equals 0, how much is v means when t equals 0, the question says it was at the origin, means when t equals 0, x equals 0. They are saying it in the question. When t equals 0, that is the question, it says when t equals 0, t passes through the origin O and the x is measured from O. So when t equals 0, x equals 0. If x equals 0, how much will be v? Substitute when t equals 0, x equals 0. When x equals 0, v equal 1. Substitute x equals 0, you will get v equal 1. So the limits here 1. Is it when t equals 0, x equals 0? The question says it was at origin. When x equals 0, how much will be v? That is v equal 1. When t equal t, we need to get a relationship in terms of t and v. T equal t, v equal v. We need to get the relationship between these two variables, v and t. Okay, so I integrate the continue here. So that's going to be integral of v to the power minus 4 by 3 dv equal 3 integral dt 1 t here 0 here 1 v. So when you integrate v to the power minus 4 by 3, you have to add plus 1 to the index. So it will become minus 4 by 3 plus 1, v to the power minus 1/3. So it's going to be v to the power minus 1/3 over minus 1/3. Is it? The limits 1 to v equal 3 t, the limits will be 0 to t. Okay, solve it. You will get, so minus 1/3, the 3 will go up. So that 3 and this 3 will get cancelled. Is it? So you'll get minus, I'll take it out, minus 1 over v to the power 1/3. This 3, when it goes up, it will become 3 here. Here 3 will get cancelled. So that's minus, I took it out. So v to the power minus 1/3, I put 1 over v to the power 3. 1v equal, so 3 got cancelled. So it's going to be t minus 0. So t. So this is going to be minus 1 over v to the power 1/3 minus 1 equal t. So it's going to be multiplied inside by the minus. So it's going to be 1 minus 1 over v to the power 1/3 equal t. So from this, take it to the right. 1 over v to the power 1/3 equal 1 minus t. So make this one subject. So that will become, so I'll write it here. So that means v to the power 1/3 is equal to 1 over 1 minus t. Take both side you cube it. So v is equal to 1 over 1 minus t to the power c. That's the relationship. So this is the first method for the big part of question number 4. There is another method. We can directly go from the equation given for v, integrate that dx over dt. Then from that we get a relationship between x and t directly. Then we can convert that format comes, 2x plus 1 comes. So from that we can relate to the v. And I'll do that part also, that method also. So okay, method 2, now big part, method 2. So it's given like v equal 2x plus 1 3 by 2. P means dx over dt equal 2x plus 1 3 by 2. So integral of dx over 2x plus 1 3 by 2 equal integral of dt. What could be the limit here? So okay, the limit is when t equals 0, x equals 0. Is it when t equals 0? That question says that it's passing the origin when t equals 0. I put it on the diagram. T equals 0, x equals 0. When t equals t is a variable, the distance x. We'll get a relationship between x and t here. Okay, so first you need to integrate this one. So when you integrate this one, it comes integral of 2x plus 1 minus 3 by 2 dx 0 to x equal 0 to t dt. I can integrate, but I put that thing. Okay, so when you integrate this one, you know, you can replace 2x plus 1 as capital X, and you can do by replacement method. Or we know that it becomes minus 3 by 2x plus 1 to the power minus 3 by 2 and plus 1. It will become 2x plus 1 minus 3 by 2 plus 1 minus half over minus half into, when you differentiate that, you will get 2, so there should be half. Remember that. So the general format, you know, when you are differentiating, like 1 over ax plus b to the power n integral dx, we can write this integral of ax plus b to the power minus n dx. So when you integrate it, it should be ax plus b to the power minus n plus 1 over minus n plus 1 into 1 over a. If you differentiate it, you will get this one. Differentiate this and a comes, that will be 1 over 4. Okay, so I'm using that pattern. So into half, yes. The limits will be 0 to x is equal to t 0 to t. Okay, so this half, these two goes up, they'll get cancelled. So there is a minus sign, minus 2x plus 1 to the power of 1 over. Minus 1 over 2x plus 1 to the power of half. The limits 0 to x minus here is equal to t minus 0. So that's going to be t here. Okay, so now substitute here 1 over 2x plus 1, the minus is outside. If you substitute 0, 1 over 0, 1 minus 1, so it's going to be minus, I'm step by step writing, 1 over 2x 2x plus 1 to the power of half minus 1 equal to t. Multiply by minus 1 inside, so it will become 1 minus 1 over 2x plus 1 to the power half equal t. But we know that v is equal to 2x plus 1 to the power 3 by 2. So 2x plus 1, we know that v is equal to 2x plus 1 to the power of 3 by 2. So 2x plus 1 to the power half means, so both sides take cube root, we will take v to the power 1/3 equal 2x plus 1 to the power half. Is it? When you take both sides cube root, this cube will become here cube root and 2x plus 1 to the power half. So 2x plus 1 to the power half, we can substitute v to the power 1/3. So this is going to be 1 minus 1 over v to the power 1/3 equal t. Am I right? 2x plus 1 to the power half, 2x plus 1 to the power half is v to the power 1/3. Because v equal 2x plus 1 to the power 3 by 2. So take both sides cube root, this will become half, so this cube will vanish, it will become 1/3. Okay, so make the v subject. So if I continue on the other side, so it's going to be, if I take 1 minus t is equal to 1 over v to the power 1/3. So v to the power 1/3 equal 1 over 1 minus t. So v is going to be 1 over 1 minus t. Okay, so it's implicit. Okay, question number 5. This diagram is given. A particle P of mass m is attached to one end of light inextensible string of length a root 3, this length. The other end of the string is attached to a fixed point A. The particle P is also attached to one end of a second light inextensible string which connected to B. So this is length is A, this length also. So B is below A, the distance between A, B is A, right? The question is, the particle P moves with constant angular speed omega. So it's moving on a circular path at constant angular speed. So this is the center of the circular path. So any questions related to circular motion, first you must be able to identify the center of the circular path, that is O in this question, because the particle is moving in horizontal circle with the support of two strings PA and PB. The lengths are given A root 3 and A this length. B is below A at a distance A. They all on a same vertical line ABO along the same vertical line, that also mentioned in the question. Then you must be able to identify the actual forces acting on the particle. Then the resultant force, when you resolve the actual forces towards the center of the circular path, that is called centripetal force, which is given by mr omega squared or mv squared over. You must know these things when you are handling question related to circular motion. So first part, show that the upper string makes an angle 30 degrees. So this angle 30 degree with the downward vertical. Okay, so we'll find it. So we know this is the radius of the circular path. This is the radius of the circular path. So this angle, if we take theta, in the triangle APB, this is also theta, because the length AB is equal to PB. Both are the same length. So in this triangle APB, AB is equal to PB. Therefore, if this is theta, this is also theta. So this angle, the external angle, is equal to sum of the internal opposite angles. So this is equal to 2 theta. In this triangle, this extended line. So this angle PBO, this angle is 2 theta, because theta plus theta, 2 theta is O-level geometry. Okay, so we know the radius of the circular path is PO. This is 90 degree. ABO is a vertical line. PO is a horizontal line. That is the radius of the circular path. So we know that PO could be given in terms of PB by considering the right angle triangle PBO. Also, the PO could be given in terms of PA by considering the right angle triangle POA. So by using them, we can give the same radius R. So in the right angle triangle, so I am answering A part, the triangle PBO, PO, that is R, is equal to PB sine 2 theta. So PB sine 2 theta means PB means A sine 2 theta. When you consider the right angle triangle PAO, same PO is equal to radius PAO. PO is the radius, that is equal to A root 3, that is, this is A root 3 sine theta. But both are the same radius. Therefore, A sine 2 theta must be equal to A root 3 sine theta. So therefore, A sine 2 theta is equal to A root 3 sine theta. But we know that sine 2 theta equal to 2 sine theta cos theta. So that we can write. So 2 sine A times 2 sine theta cos theta equal to A root 3 sine theta. A and A will get cancelled. Here also I would have cancelled A, but it's okay. A get cancelled. Sine theta will get cancelled. So remaining 2 cos theta equal root 3. So cos theta equal root 3 by 2. So find the theta, that will be 30 degree. So theta means the string PA will make an angle 30 degree with vertical. So show that the upper string makes an angle 30 degree with the vertical, with the downward vertical, and the lower string makes 60 degree. So we know that lower string PB, that is therefore 2 theta equal to 60 degree. So we found both in the first part. Okay, so second part, show that the tension, the B part, show that the tension in the upper string is, they are giving an expression half m root 3 2g minus a omega square. Omega square is given, the particle is rotating at constant angular speed. Okay, for that we will think about the actual forces acting on the particle P. So if I draw the forces acting on the particle, actual forces, this is the particle, its weight is acting vertically down mg, the mass is given m. Then the upper string will provide, now you know I told that when a particle moves on a circular path, it has intention of moving away from the center, that is called centrifugal effect. So the particle has intention of moving away from the center means, so that's the reason it exerts tension on both strings, because it tried to move away means it's tried to stretch the string, so there will be tensions. So the upper string, the tension we can name it T1. This is T1 in the upper string. That makes an angle theta with vertical. So this angle theta, we already found the angle theta. Then the lower string or the bottom string PB, this let it be T1. We'll call this upper string, the tension exerted by the upper string T1. The lower string makes an angle with the vertical 2 theta. So that is T2, that makes an angle with the vertical 2 theta, means with this theta, so with this theta I can show the total angle 2 theta with the vertical. So the center of the circular path is O, that is somewhere here. This is the center of the circular path. Okay, so since the particle is moving on a horizontal circle, there is no vertical displacements. So the vertical resultant force must be equal to 0, is it? So we resolve all the forces vertical direction. T1 cos theta plus T2 cos 2 theta. We'll substitute the values. T1 cos theta plus T cos 2 theta minus mg equal to 0. But we know cos theta equal 30. So T1 cos 30 plus T2 cos 60 equal mg. Cos 30 root 3 by 2. So root 3 by 2 T1. This is half T2 equal mg. And we will bring it to a standard format. So root 3 T1 plus T2 equal 2 mg. So root 3 T1 plus T2 equal 2 mg, the first equation. Okay, so we know that centripetal force is the resultant force towards the center of the circular path. So this is the actual forces acting on it. Center is here, the weight is vertical, center and the vertical, the angle between the weight and the line that makes the radius 90 degrees. So the weight has no component towards the center of the circular path. But the resultant force towards the center is only due to T1 and T2. So we'll write along towards the center, that is T1 sine theta plus T2 sine 2 theta equal mr omega squared. mr omega squared. Okay, so we'll substitute. But what is R? How much is it? So in this one, R is equal to A sine 2 theta or R equal to A root 3 sine theta, either one. So A sine 2 theta, theta is 30 degree, A sine 60 is root 3 by 2. So R is equal to A root 3 by 2, because Either one you use it. R equal A root 3 sine theta. Sine 30 is half, so you will get A root 3 by 2. Or use this one, A sine 2 theta. Sine 60 is root 3 by 2. Whatever it is, you will get the radius, that one. Okay, now we will substitute the values here. Sine theta, so T1 sine 30 plus T2 sine 60 equal M into its of R A root 3 by 2 omega square. Okay, solve the value. So sine 30 half, sine 60 root 3 by 2. So substitute the values and solve it. You will get an equation T1 plus root 3 T2 is equal to A root 3 M omega square. Okay, so this will be the second equation. Okay, the question is show that the tension in the upper string. So we need to get an expression now for T1. So there are two equations. So we need to eliminate T2. So now O-level quadratic, simultaneous equations. So multiply first equation by root 3. So this will get it. If you multiply first equation by root 3, you will get root 3 into root 3, 3 T1 plus root 3 T2 equal to root 3 mg. That will be third equation. Okay, so now we'll subtract 3 minus 2. 3t1 minus t1, that is 2t1. Root 3 t2, root 3 t2 will get cancelled. So 2 root 3 mg, a root 3 m omega squared. So 2 root 3 mg minus a root 3 m omega squared. Okay, so we'll rearrange it into the format what they asked. So divide by 2, take the m out. So t1 is equal to, if I take m out of the bracket, here 2 will divide it. So you'll get half m. That means 2g, yes. Half m root 3, we can take root 3 also out. Yeah, root 3, we can take it outside if we take it. So then remaining part is 2mg, yeah, 2g minus half we took it, so there will be a omega squared. Yeah, correct, no? Yes. So this is the thing they asked to show, right? We got the answer. Okay, C part. So that's all B part. Now C part, they ask you to show the range of omega square, the possible range of omega square to satisfy this type of motion. That means it's an inequality format. So how can we get it? There's nothing to tell about it. Only thing we can say, the particle is moving in horizontal circle. It has intention of moving away from the center. So it stretches both strings. So there will be tension as shown here. These tensions are real positive values. They are real values. They are positive values. So we'll get it from there. So C part, we can say T1 greater than 0 because it's a real positive value. If the particle is in motion, that means strings are not slagging. Particle has intention of moving away from the center. So if it is continuing in motion, it should have intention of moving away from the center due to centrifugal effect. So both strings should be stretched. So T1 must be greater than 0. Also T2 greater than 0. Both should have the real positive value, the tension. So we need to find the T2 also here. So to find the T2, we'll substitute this value in one of the equations. So from the first equation, if I substitute, I'll get the expression for the T2. So root 3 into T1. So multiply this by T1, root 3. Then substitute here and find the T2. You know how to solve it. You get the value, solve it. So you will get T2 is equal to 3 by 2 MA omega squared minus mg. This is the value you will get it when you substitute the value of T1, this expression, in first equation or second anywhere, but if you substitute here, that's easy. Multiply by root 3. So it will be root 3, it will be 3 by 2m. So when you take it inside, 2 will get here 3 mg minus 3a omega squared. Put it here, make the T2 subject, you will finally end up with this format. 3 by 2 ma omega squared minus mg. Both must be positive quantities because the particle is moving in a horizontal circle. If it is moving in a horizontal circle, both strings have to be stretched. If they want to have stretch force, that means tension, both tensions must be a positive quantity. So we'll continue that from here. So both T1 and T2, C part, T1 greater than 0 and T2 greater than 0. So T2 greater than 0, we'll start from that. T2 greater than 0 means 3 by 2 ma omega squared minus mg must be greater than 0. So take it to the other side. So that means ma omega squared must be greater than 2 by 3 mg. Is it? So m will get cancelled. So omega squared must be greater than 2g over 3a. Right. Then this is from T2 greater than 0. So I got this from T2 greater than 0. From that I got it. So T1 greater than 0. So T1 greater than 0 means this one half m root 3 2g minus a omega square greater than 0. This is a positive quantity. I can divide whole equation. The sign won't change. If it is a negative, sign will change. But here this is a positive quantity. So I can divide the whole equation, this is a whole inequality, by half m root 3. Therefore 2g minus a omega square greater than 0. That is a omega square less than, take it to the right, less than 2g. That is omega square less than 2g over a. So you know that omega square greater than 2g over 3a, omega square less than 2g over a. So that means omega square greater than 2g over 3a less than 2g over a. That's the inequality they asked to show. Simple. There's nothing. We need to consider only the particle is moving in horizontal circle with the support of two strings. To have that condition, this is the condition. Okay, question number 6. A small smooth ring R of mass m is threaded on a smooth wire or in the shape of a circle with a center O. So this is a small ring, it's threaded there, right? And it's on a smooth ring, shaped circular wire, right? The radius L, so the radius is L. The wire is fixed in a vertical plane. The ring R is attached to one end of the light elastic string of natural length L. So this is a elastic string. Its natural length is L. The radius of the circular this wire is also L. So the radius is L. The length, the natural length also L. So when the ring is at highest position, the bottom end of the elastic string is attached to A, means the total length is 2L. That means extension at this position is 2L minus L, that is L, right? The point B is on the wire and OB is horizontal. So there is a point B, that is OB is horizontal. The ring R is at rest at the highest point of the wire. So here it's at rest. So we can say initial speed is 0. So initially it's at rest here. The The ring R slightly disturbed from rest and slides along the wire. At the instant R reaches the point B, the speed of R is V. So when it reaches this point, its speed is along the tangent, that is V. The magnitude of the force exerted on R by the wire, magnitude of force exerted by R on magnitude of force exerted on R by the wire is capital N. So it's like a no contact force. Show that V squared equal 2GL root 2. Okay, so the speed when it reaches B, when it becomes horizontal, we need to find the speed. So here the when the particle, when the ring is allowed to move from the highest point, it's moving from highest point to B due to pull by the elastic string. There's a tension also acting on it. So there we can write loss in gravitational potential energy, because the ring has mass m, so it's moving from here to here. Loss in gravitational potential. So the height vertical it moved down is equal to L. When it moves from this position to this position, the vertical displacement, it was here, now it is here, means it has gone down from here to here, which is equal to L, the radius. So loss in gravitational potential energy equal to and also its extension is decreasing, extension of the elastic string also decreasing. So at this position the elastic string possesses elastic potential energy, which is equal to half into lambda over L x squared, we can find the initial extension, it's squared. When it is at B, the length of the string we can find it by using Pythagoras theorem, so they are also extension, but the extension will be smaller compared to when it was here. So the string, the elastic potential energy is decreasing. So we can write loss in gravitational potential energy plus loss in elastic potential. Both are lost and converted to gain in kinetic energy. Here the kinetic energy is 0, here there is a kinetic energy. By equating these energy equations, we can get the expression, but they asked to show V squared equal 2GL root 2. Okay, first we will find the A part. First we will find the extension at highest point. We'll name it AB. We'll name this point as C. Extension at C equal to L minus L, that is equal to L. So elastic potential energy at C half lambda over L x squared, that is lambda is given modulus of elasticity given mg, so half mg over L x squared is L squared. So that is going to be mgl by 2, right? So that's elastic potential energy at C. So at B, what could be the length? So if we find the length AB, so the length AB if we find, we can find the extension at B. So AB is equal to, Pythagoras theorem if I use, this is L, square root of L squared plus L squared, that is going to be L root 2, that is the length AB. So extension at B, equal L root 2 minus L, that is L into root 2 minus 1. Okay, so elastic potential energy at B, half lambda over L, lambda is mg over L into extension square, that is L squared root 2 minus 1 all in squared. Solve it, you will get it. Extend, if you square it, it will become square root of 2 plus 1, 3 minus 2 root 2. So solve it, you will get 3 mgl by 2 minus mgl root 2. Solve it, you will get that one. Okay, so we can write the energy equation now. Loss in EP for the motion from C to B, loss in elastic potential energy plus loss in gravitational potential energy. Both are lost and it's converted to gain in kinetic energy. So like a law of conservation energy, when a particular type of energy is lost, it will be converted to some other format that will become the gain in energy. So these two are lost, it will become gain in kinetic energy. Loss in EP, so energy, elastic potential here minus elastic potential here is the loss in EP. So that is EP at C mgl by 2, that is energy at C minus 3 mgl by 2 minus mgl root 2, that is the loss in EP. Loss in GP, gravitational potential, mgh, so the vertical it has gone down L, so mgl equal to gaining kinetic energy half mv squared minus, initially it has no kinetic energy because it was at rest. Okay, solve it and make the v squared subject, you will get the final expression. Okay, solve it. This is mgl by 2 minus 3 mgl by 2 plus minus mgl root 2 plus this one mgl equal half m v squared. Okay, so mgl by 2 minus 3 mgl by 2, so this is when you consider these two, this becomes minus 2 mgl by 2 means minus mgl plus mgl will get cancelled. So finally mgl root 2 equal to half mv squared. M will get cancelled, so v squared equal get cancelled, 2gl, yeah, they have to show that, yes, 2gl root 2. That's the thing they have to show. Okay, so the part C, for that I drew the diagram here. When the ring comes to the position B, the elastic code is this one. We know the tension already, we got the equation for that. Okay, the question is N. N is the contact force between the ring and the circular wire. N equal half mg 5 root 2 minus 2. Okay, when it is at this position, there will be two forces acting on the ring. If I draw the ring like this, there will be two forces acting on the ring. One is the normal reaction exerted by the normal reaction or the contact force between the circular wire and the rim. That is, we can show it either this way, and they show it this way or this way, because actually which way will it exert depends on the way the ring touches the circular wire. So imagine if this is the circular wire, if the ring is touching like this, that means due to the pull by the wire, if it is touching like this, so the ring will pull the wire towards this direction. So wire will exert normal reaction on the ring this direction. But if the ring is like this, if the ring has intention of moving away from the center due to centrifugal effect, but if it is touching like this way, something like this, the left edge is touching like this way, then the ring will pull the wire away from it. According to Newton's third law, wire will exert the normal reaction this direction. But anyway you can take it, no problem. Final answer will become negative other way. So anyway you have to finally invert the direction. Doesn't matter, whatever the direction you take is not a problem. But I took it towards left, the normal reaction. So the tension exerted by the wire will act from here, this direction. This is the tension. This angle we can find it because this is L, same, this is same, so this is 90 degree, means these should be 45 degree. Is it? Because this is 90 degree, this is L, means each of these sides will be 45 degree. Okay, so these are the two forces acting on it. Now we need to write the equation for centripetal force, that is the force towards the center of the circular path. We know the speed v squared at the position B, we got the expression for that. So centripetal force is the resultant force towards the center, so that will be towards center, or the centripetal force F equal N plus T cos 45 equal mv squared over r is L. Right. So we know what could be the tension when it is at B. We already got it. Tension is equal to. We found the extension, that is I found the extension in the A part, that is L into root 2 minus 1. So tension is equal to lambda over L into x. So that is lambda is given mg over L into x is, I already found it in the first part, that is L root 2 minus 1. So L will get cancelled. Mg root 2 minus 1 is the tension. So that is mg into root 2 minus 1. That is the tension at B. So we'll continue from here. So N plus, instead of T, mg root 2 minus 1 cos 45 1 over root 2 equal m v squared over L. We got an expression for v squared, that is 2gl root 2 2gl root 2. We got it in the first part over L. So anyway, this L and this L will get cancelled. So it's going to be N is going to be N equal L get cancelled, 2mg root 2 or 2 root 2 mg, we'll write that way, 2 root 2 mg minus mg root 2 minus 1 over root 2. Okay, so from this we had to solve and get the format what they asked to show. We had to get it from this equation. Okay, to get that format, we have to multiply numerator denominator by root 2. So 2 root 2 mg minus multiply numerator denominator by root 2. So there will be root 2 mg root 2 minus 1 over root 2 into root 2, 2. Okay, so they asked to take half out. Half, you can see the format they are showing it, final answer. It says half mg, will take it out. Half mg, if I take it within brackets, so I took it half, so this will become 4, is it? Half mg, I took it. So 4 root 2, there will be 4 root 2. If you multiply here, you will get 2 root 2 mg. Multiply 2 root 2 mg. Minus this half, I took it. Mg also root it. Took it. So remaining is minus root 2 into root 2 minus 1. Check it. This half I have taken from here. Root 2 into root 2 minus 1. So that will be half mg 4 root 2 into root 2 minus 2 minus root 2 into minus 1 plus root 2. Is it? 4 root 2 plus root 2, 5 root 2, is it? 4 root 2 plus root 2, 5 root 2. So I'll continue here. So final answer, n is equal to half mg 4 root 2 plus root 2, 5 root 2 minus 2. This is the answer they asked to show. So what to do? We had to get the final expression, but they asked to show. That's what I did it. Yeah. In case if you take the n other way, you will end up with minus answer. That means you will end up with like this. If you take the n is towards right, you will get this format. N equal half mg 2 minus 2 root 2, you will get it. So, but you know that 2 minus 5 root 2, you will get it. So 5 root 2 is greater than 2. 5 root 2 is greater than 2. So 5 root 2 greater than 2 means this is a negative answer, means n is going to be negative, so it should be towards left. So from that you can get it, no problem even if you take it other way. But we'll end up with like this. Okay, question number 7, the last question. 2 points A and B lie on a smooth horizontal table AB 4L, the length. A particle P of mass M is attached to one end of light elastic spring. This is particle P, one end of light elastic spring of length L and modulus of elasticity 2 mg. The other end is attached to A, so this is 2 mg. So here the lambda 1, 2 mg. The natural length is L, right? The natural length of AP, L, right? Okay. The other end of the spring is attached to A. The particle P is also attached to one end of another light elastic string. Elastic spring of natural length L. So that also same natural length. Modulus of elasticity mg. So lambda 2 equal mg. The other end of the spring attached to B, the particle P rests in equilibrium on the table at a point O where AO is 5 by 3L. AO is 5 by 3L when it is at the equilibrium position. Equilibrium position means position at which the resultant force equals 0 is called equilibrium position. The particle P is moved a distance half L along the table from O towards A. So they are displacing it towards A. Half L along the table from O towards A. So they are pulling it towards A, this direction. They are pulling it through a distance of half L and released. Show that P moves with a simple harmonic motion of period T. Okay, so whenever they ask to show simple harmonic motion, we will take its move towards left through X. So it moves towards left through X. So this is the position P. So the P is here. Move towards left through X, we'll take it. Okay, so initially, what could be the extension? We'll find it. X1, X2. X1 means for lambda 1, X2 for this string. So X1 is equal to, the length is L, 5L by 3 minus L, that is going to be 2L by 3. X2 is equal to, for the right side string, X2 is going to be, this is 4L, this is 5L by 3, so 4L minus, 4L minus 5L by 3, that is PB, minus L, that's natural length, that will be the extension of the spring OB. So that spring OB, the extension is going to be 5L by 3 minus L, 4L by 3. So that extension is more than this extension. Okay, so now what's happening? It's moved towards O from rest through a distance X. We'll take it move towards X. So when it is moved towards X, but anyway they are showing it's moved towards L by 2. So if it is moved towards L by 2 is the extent, they are pulling it towards left through L by 2, but whenever they ask to show it follows simple harmonic motion, show that P moves with simple harmonic motions, we need to get an expression in the form of, finally we get x double dot equal minus omega squared x. So we have to take the displacement as a variable x. Okay, so the extension of the x1 will decrease by x, extension of the x2 will increase by x. So if I draw the forces acting on the particle, this side T1, this side T2, right? So now T1, when it is moved from O to position, we'll call it as position ABC, the position C, right? When it is at C, what could be the tension? We should take along the direction of displacement positive. So F is equal to T1 minus T2 equal mx double dot. So I'm taking towards left because the displacement is towards left, that direction must be taken positive. Then automatically you will get the final equation x double dot equal minus omega squared form x. So T1, how much will it be? T1 equal lambda 1 over L1, is it, into extension. Now this is 2L by 3 when it was at equilibrium position minus x, because it's moved towards left means extension will decrease by x minus T2 lambda 2 over L2 x2 plus x. That is x2 we got it. x2 is 4L by 3 plus x equal to mx double dot. mx double dot. Okay, solve it. This one lambda 1, you know that lambda 1 2 mg. L1 that is L 2L over 3 minus x minus lambda 2 that is mg over L 4L by 3 plus x equal mx double dot. Okay, solve it. You will finally get the correct expression. So that is L will get cancelled. 4mg over 3 minus 2mgx over L minus L get cancelled. 4mg over 3 minus mgx over L equal mx double dot. Okay, so 4mg over 3 minus 4mg over 3, they will get cancelled. Minus 2 mgx over L minus mgx over L, so that means minus 3 mgx over L equal mx double dot. So rearrange it in the form m will get cancelled, so x double dot equal to m will get cancelled, x double dot equal to minus 3g over L x. Now look at here, this is in the form of x double dot equal minus omega square, because 3g over L is constant, omega square is constant for a simple harmonic motion, so this is a constant. Therefore x double dot equal minus omega squared x format, where omega squared equal 3g over L. Therefore hence x double dot directly proportional to minus x. Therefore you have to write finally it will have a single harmonic motion, and omega squared 3g over L. Okay, so they are asking to show that the time period. So omega squared 3g over L. So how many marks? It's 6 marks. Yeah, that's the highest marks in that question. So omega squared equal 3g over L. We know that omega equal 2 pi over t. So omega equal 2 pi over t square root of it, that is square root of 3g over L. So t is equal to 2 pi square root of L over 3g. That's the thing they asked to show that. We showed it. Okay. Okay, so B part, they also show that find in terms of L and G the speed of T as it passes through O. O is the equilibrium position where the resultant force equals 0. So remember that when a system is at rest, when it is at rest, if it is pulled from the equilibrium position through a particular distance and released, the amount, the displacement through which it is pulled will become amplitude during the oscillation. For example, from the equilibrium position, if it is pulled towards left through, for example, 5 cm and released, during the oscillation 5 cm will be the amplitude, because when you release it at that point the initial speed is 0. Initial speed is 0 means where it has the maximum displacement position. So during the oscillation that will become the amplitude. Here the particle is pulled towards A from the equilibrium position to a distance of half L, L by 2. So second part, the B part, the amplitude is going to be L by 2. We know the equation V squared equal omega squared A squared minus x squared. Here x is the displacement that is measured always from the equilibrium position. They asked to find the speed at the equilibrium position. So x equals 0. What is the speed at x equals 0 is the question. So V is equal to V squared equal omega squared. We know that 3g over L a squared, that is L squared by 4 minus 0, because at x means, at O means x equals 0. So it's going to be 3g L by 4 is v squared. So v is equal to square root of 3gl over 2. That's the maximum speed actually. Okay, C part. Find the maximum expression in terms of, that's the question, C part. Find in terms of G the maximum acceleration of P. So we know that acceleration x double dot equal minus omega squared x. That minus sign indicates always the direction of the acceleration opposite the direction of displacement. But when we consider numerical values, we don't need to consider minus sign. So omega squared x. So maximum acceleration, maximum occurs, this is constant when x becomes maximum. X becomes maximum means at the amplitude. Okay, so that is omega squared, we know that 3g over 2l, amplitude L by 2. So that is 3g by 2. That is the maximum acceleration. Okay, part D, the last part of this last question. Find the exact time in terms of L and G from the instant when P is released. So from the instant P is released, so it's pulled to the left by L by 2 and released. From the instant it's released, from rest to the instant when P first moving with speed 3 by 4 GL. So it is released. What's the time taken for the particle to move from the rest position to a speed of 3 by 4 square root of GL. Okay, so here the time is taken from the moment it's released. From the moment it's released means from the extreme position. So the equation that relates the displacement and time, there are two equations, x equal a sine omega t, x equal a sine omega t, other one is x equal a cos omega t. So where to use which equation you must know. If the particle was released, or we are going to consider the motion from extreme position, that means where the maximum displacement position to some other position later, means we should use this equation, because when you substitute t equals 0, you will get x equal a. That means when t equals 0 means you are going to measure the time from the position at which the particle is maximum displacement. So when t equals 0, x equal a means initially, or you are going to measure the time when the particle is at the maximum displacement position, then later at a position. This we use when t equals 0, x equals 0. That means initially if the particle is at the equilibrium position, or you are going to measure the position or measure the time taken for a particle to be at a particular displacement from the equilibrium position, how long it takes to move from equilibrium position to some other position, then we use x equal a sine omega t. So here the particle, the question is how long it takes to gain a velocity of 3 by 4 square root of GL from the moment it is released from the extreme position, means we should measure the time from the position it has maximum displacement, where the speed is 0, is it? So we have to use this equation. So part D, x equal a cos omega t, but this is related to speed, so I need to differentiate this equation with respect to time. So dx over dt is equal to a cos omega t. If you differentiate, you get minus sine omega t, but I don't need the minus sign because again that shows the direction, so I'm dealing with only the expression. So a sine omega t, a omega sine omega t, a omega sine omega t, a omega sine omega t. Minus sign I don't need it here because that is indicate the direction. Okay, dx over dt is the speed. So v is equal to a omega sine omega t. So the speed At what time the speed will become 3 by 4 GL. So 3 by 4 square root of GL is equal to A. That is amplitude, we already found it. We already told that it's pulled through L by 2 and release. So from the equilibrium position, if you pull it through a particular distance and release, that will be the amplitude. So L by 2 omega, we found the omega, that is square root of 3g over L. 3g over L, that's the omega, into sine omega t. Okay, solve it. So when you solve, so square root of 3g, square root of g, L, so L square root, here there will be square root. You solve it, you will get sine omega t. Sine omega t is equal to root 3 by 2, you will get it. Check it, solve it. You get sine omega t root 3 by 2. If you have difficulties in solving, I will solve it. This we can write like this way, no? This is 3 by 4, so here 2, here 4, so I can write 3 by 2 square root of GL. When this L goes into the square, it will become L squared, is it? So square root of 3GL squared over L, so it will be square root of 3GL sine omega t. Okay, so here there's square root of 3 is there, so this I can write square root of 3 times square root of GL sine omega t. Square root of GL will get cancelled. So here 3, here square root of 3. So when the square root of 3 comes down as a denominator, 3 over square root of 3, it will become square root of 3. So square root of 3 by 2 equals sine omega t. So omega t is going to be sine inverse 3 root 3 by 2. If you take it in radian, that will be pi by 3. That is 60 degree. But we have put it in radians, pi by 3 omega t. Okay, so omega t equal pi by 3 means we need to find the time. T is equal to pi over 3 omega. We know omega equal 3 square root of 3g over L. So pi over 3 into omega. So this is 1 over omega. So square root of L over 3g. So that this is the answer. Final answer is this one. Pi by 3 square root of L over 3g is the time taken. Okay, so that's the end of paper discussion. This is January 2023. We'll meet during another paper. Yeah, you can pass your comments. How is the explanations? Bye.